And looking at number 2, the tank contains 125 gallons of heating oil at time t equals 0. During the time interval 0 to 12, heating oil is pumped into the tank at the rate of h of t. During the same time interval, heating oil is removed at the tank at r of t. So, A, how many gallons of heating oil are pumped into the tank from the time interval? We've got 0 to 12 is our time interval, and we've got a rate of h of t. To find how much from a rate, all we have to do is take our antiderivative, 0 to 12, and again, because it's calculator active, we can just write h of t. Plug that into our calculator and say 70.571. Gallons is going to get you a point on this using correct labels. So 70.571 gallons. Is the level of heating oil in the tank rising or falling at time t equals 6? Give a reason for your answer. So we've got our rate at which we're going in, which is h of t, and our rate at which we're going out. So we really just want to compare what is h of 6 compared to r of 6. Plugging it into my calculator, h of 6 is 5.395 and r of 6 is 8.319. So if my amount removed is greater than my amount putting in, the level of the tank should be falling. And don't second guess yourself. You've shown that the rate at which it's going out is bigger, it's falling. That's enough justification. And see how many gallons of heating oil are in the tank at time equals 12. So if the tank contains, the key to this problem is always like remembering what the initial condition was. If we've got 125 and we've added in 0 to 12, everything that we've pumped in, the rate of h of t, minus everything we've taken out, the rate of r of t. Straight up, calculate the calculator, we should get 122.025 gallons. And I think, putting this in our calculator, second calculate, putting this in our calculator, second calculate, using the numbers, plenty. And then D, at what time t for 0 to 12 is the volume of the heating tank the least? Show the analysis that leads to your conclusion. So we're looking for the least, and we're looking for the least volume. And we calculated volume in the last one, which was 125 plus the integral from 0 to 12 of h of t minus the integral of 0 to 12 of r of t. So to find a minimum, we need to find the derivative of volume. The derivative of volume is going to be equal to 0 plus, our fundamental theorem of calculus says that the derivative of this guy is going to be h of t minus, and these really shouldn't be 0, this should be like 0 to x, that's why we'll keep the h of t, minus r of t, and we want to set that equal to 0 to find our critical points. So h of t equals r of t is our critical points. We should still have it in our calculator from calculating part C. So we find where they intersect, second calculate intersection, is at t equals 4.790, t equals 11.318. And in calculus, we need to remember these are our critical points. But we also need to remember it could also happen at an endpoint. So we can find our volume using our volume equation for 0, our volume for our two critical points, 4.790, our volume at 11.318, and our volume at 12. Now we've actually calculated our volume at 0 is 125. We calculated our volume at 12 in part C. That was 122.025. So then we just need to calculate our volume at 4.790. Same way we calculated it in C, really. That'll give us 149.408 when we put it in our calculator. And C, or N 11.318, 120.026. So finish the problem by saying the volume is the least at time 11.318. And were we talking about hours?